dy dx minus 4y over x equals 2y squared x. So let's use the Bernoulli's equation substitution. V equals y to the 1 minus n. Here everything's arranged in the correct positions, and the value of n is 2, so it's 1 minus 2, which is y to the minus 1, which we can write as 1 over y. So dv dx then, let's differentiate both sides. This differentiates to minus y to the minus 2 multiplied by the something differentiated, which is dy dx. So let's rearrange it for dy dx then. Is equal to, move the minus over to be with dv dx, which I'll write here. There's the minus. This y to the minus 2 is like a 1 over y squared, and it moves up to times on the other side, so you can put a y squared here. So that's what we've got. So substitution then into the above gives dy dx equals this, so we've got minus y squared dv dx minus 4y over x equals 2y squared x. There we go. So let's turn our attention to this now. Divide by y squared all the way through. And that gives, with a minus, so we'll just get left with dv dx here, which is what we want. And then that becomes a plus, and it's 4 over x times 1 over y, isn't it? Because there's a y that cancels with one of the y squareds. And the 1 over y we can write as v, because that was our original substitution. And here we've got divided by y squared, you're just left with 2x. There we go. So we divided by, I'll just correct myself here, minus y squared, so that gave us that. Here the minus is made a plus, and divided by y squared was 4 over x and with 1 over y, which we put in v there. And then divide this by minus y squared. The y squared cancels and we do get a minus come in here. So now we can mark off p for integrating factor method. There it is there. So we can do here the integrating factor e to the integral p, which is 4 over x dx, which equals e to the 4. 1 over x integrates to 4 log x, and then we can just remove the 4, put it up there, ln x to the 4, which equals x to the 4. There we go, because this is the inverse of the exponential, the log. So we've just got x to the 4, haven't we? So let's multiply through then by x to the 4, see what we get. So x to the 4 dv dx plus 4x cubed v equals, because one of the x's would have cancelled and we've got a 4 there, haven't we? And then we've got minus 2x times x to the 4, which is minus 2x to the 5. There we go. So that's that. Good. Now we can deal with this and read off u and v. So d by dx then of the u times v equals this thing here, minus 2x to the 5. The u and the v, it's just a matter of circling this. This position always gives the u and this thing always gives the v. So it's going to be x to the 4 times v. So integrating then, and see what we get. Gives, so what do we get? The integral of the derivative is x to the 4 times v. V we can write as 1 over y, wasn't it? Let's just check that. I've not made a mistake there by checking the substitution. Yeah, v was 1 over y, so I can put v in there. So let's go back down. So this integrate is x to the 4 times 1 over y equals the integral of this, minus 2 lots of the integral of x to the 5 dx, which equals, so you've got x to the 4 over y is equal to minus 2x to the 6 over 6 plus k. So I can invert it now. So y over x to the 4 then is equal to, so we've inverted that, invert this, it's going to be 1 over. This k I'll write first underneath, minus, and this is just x to the 6 over 3. There we are, put a bracket around it. And now we can move the x to the 4 up from divide to times. So now, at long last, y equals, so move this x to the fourth and divide to times, over k minus x to the 6 over 3. There we go.